Again, always make sure that the displayed value is 0 when you're measuring an object or a sample. Using a clean spatula, scoop an appropriate amount of your sample from the reagent bottle and get another clean spatula to cautiously transfer the sample into the beaker, just like in the video. When you have reached your desired amount, in which in this video it was 0.2 gram of solid sample, do not ever return the unused chemical to its original container. This is important because in doing so, you might contaminate the entire contents of the reagent. Just simply discard the unused chemical exactly as instructed in the waste disposal instructions, and please label the container as waste. And now you're done. So that is how you measure your sample using the direct weighing method. Thank you.
Okay, so that's the first basic skill for chemical analysis. Now it's time for me to explain to you a little bit more on the weighing anything on ethical balance. First of all, you have to start off with like cleaning. Okay, it's actually not shown inside the video, but it's a good practice that you start off with cleaning the surrounding of the balance, as well as checking whether it's actually in a calibrated state. Okay, how to see the ethical balance being calibrated? We can see it from the bubble, the next at the ethical balance, whether it's in the middle of the circle. Okay, so if it's in the middle of the circle, means that it's a good to be used. If it's not, okay, maybe we have to like lift a bit on the ethical balance, and also when you start to clean and also start to tear it off, then it will start to be in the middle again. Okay, if let's say we have a serious problem such as the bubble is really out of the circle, then it is an indicator for us to send it for service. Okay, that's how we weigh anything on ethical balance. Okay, I don't think this is the first time you see ethical balance, right? Nurina Batisha. Nurina Batisha, is this your first time look like having a look at ethical balance? Nurina? Nurina Batisha?
Yes, Doctor.
Okay, is this your first time watching ethical balance?
No.
So this is not your first time. When was the last time you see this? Is it last semester or last few years during matric?
Last period during matric.
Oh, okay, last few years during matric. Okay. Okay, thank you. And then I would like to ask what you see inside the video. Okay. Anybody want to answer how many decimal places of the ethical balance? Anybody want to answer?
4 decimal, Doctor.
4 decimal. Okay, who's that?
Felix.
Felix. Okay, thank you very much. Okay, chatting tidak diterima ya. Chatting is not accepted. Please open your mic when you want to answer. Thank you very much, Felix. And then who else want to answer? What's the number of the balance after that technician put in the chemical, the white chemical? Anybody want to answer? The number of the
0.2021.
Okay, sebut nama.
Anis.
Anis, Anis Najwa.
Yeah.
Okay, 0.2021. Okay, 2021, it is okay. The voiceover said that we are going to weigh 0.2, okay, 0.2000. But after you somehow you weigh and you cannot achieve 0.2000, but it's okay to take up 0.2021 provided that you jot down whatever you weigh. Okay, jangan you want to weigh 0.2 and then you get 0.2021 but you jot down the original number which is not correct. It will jeopardize the whole calculation later. Okay, last before we start again. Okay, why do you think the technician before he click the tear, he closed the lid? Anybody want to answer? Please say name first.
Edward.
Edmund, okay? Edward. Okay.
Edward. Number 28.
Okay.
To prevent the air current from affecting the reading.
To prevent the air current from, okay, good. So when you close, okay, there's no air inside it, and then you turn on the tap. Once you open it, okay, the number will start to like go up and down again, but it's okay because it will always come back to zero. Okay, so that's good. Shows that most of you pay attention. Okay, this morning we will continue, and it will be for the rest of the video. Yeah.
Hi, welcome back. Moving on to part 2 of the basic experiment. The demonstrator will now show you on how to use the pipette correctly. So for this purpose, you'll be needing a pipette and its bulb, beakers for waste disposal and for transferring your liquid samples, you will also be needing conical flasks for your liquid sample. And lastly, of course, your stock solution. So firstly, you'll need to rinse the pipette with distilled water. Draw the distilled water into the pipette. Tilt and roll it to make sure that the interior of the pipette is rinsed thoroughly before removing the bulb and draining the water out. Use the bulb to remove the water droplets at the tip of the pipette. You may repeat this step for at least one more or twice for ensuring that the pipette is thoroughly rinsed. Next, rinse the beaker with a small amount of your stock solution and discard it in the waste container. Repeat this step for at least one more time. Then you can finally transfer an appropriate amount of your stock solution into the beaker. Never pipette directly out from the stock solution, as there will be a high chance of possible contaminations. Once transferred into the beaker, you may insert the pipette. If you are right-handed, hold the pipette in your right hand, leaving your index finger free to place over the top of the pipette. With your left hand, squeeze the pipette bulb. Press it firmly over the top of the pipette. Release the pressure on the bulb very slowly and allow the solution to flow into the pipette. Be careful, as you do not want the solution to reach the bulb. Quickly remove the bulb and place your thumb firmly over the top of the pipette. Again, slowly roll your thumb to one side and allow the liquid to drain until the bottom of the meniscus is aligned with the volume mark. I'm sure with practice, you will be able to lower the liquid very, very slowly. Now you can take out the pipette and transfer the liquid into the conical flask by slanting the flask and make sure the tip of the pipette touches one side of the flask. Slowly drain the liquid from the pipette. When the solution stops flowing, you can touch the pipette once to the side of the conical flask to remove any hanging drops. Do not blow out the remaining solution. This is because the pipette has been calibrated to deliver the appropriate amount of solution, with some remaining in the tip. And that's all, and you're done. Hi, now moving on. So now the demonstrator will show you on how you can do a titration. First off, you'll be needing a clean burette that is firmly clamped to the retort stand. Make sure you have a white tile placed underneath for better visual on the changes of color. You'll be also needing a pipette set, your sample, beakers, reagent, distilled water. Make sure that the calibration mark is in your direction when you're clamping the burette to the retort stand. Tighten the clamp slowly as to avoid cracking or breaking the burette. Make sure there is enough space between the tip of the burette and the bottom of your stand for your beaker or flask. You may first practice to adjust the stopcock with your left hand. Next, you may transfer an appropriate amount of your reagent into the beaker. Place a clean filter at the top of the burette and a collection beaker underneath. Don't forget to make sure that the stopcock is in open position. Now carefully transfer your reagent into the beaker and let the reagent drains into the collection beaker or your waste beaker. If necessary, you may use a dropper to transfer some of the reagents into the walls of the burette. Remember, you do not want to rinse the burette with distilled water, as this might dilute the concentration of your sample. Once done, you make sure that the stopcock is at closed position. And you may transfer the remaining of your reagent into the burette with the aid of filter funnel. Make sure that the solution is above the calibration mark here. At your eye level, observe carefully as you're draining the excess solution into the collection beaker until it reaches the mark. Next, take a clean pipette and transfer an appropriate amount of your sample into the conical flask. Again, never pipette out solution directly from its container, so you'll have to transfer your sample into a clean beaker first. Then you may transfer the solution into the conical flask and mix with a few drops of color indicated dropwise. You may need about 3 to 5 drops depending on the volume of your analyte. Make sure to stir the solution cautiously. Then you may place the flask underneath the burette, and the tip of the burette should not touch the walls of the conical flask. Slowly open the stopcock so that the titrant drips out of the burette. The titrant should come out of the burette drop by drop. I repeat, drop by drop. Swirl the flask while you're at it. Then allow the titrant to drop into the analyte until you notice a color change in the bigger solution. The color change may be slight, so proceed very slowly and watch very carefully. If you notice a color change, close the stopcock and swirl the solution for about 30 seconds. If the color dissipates before the 30-second mark, open the stopcock slightly and continue to add the titrant drop by drop until you get a permanent change. Once the color of the solution changes permanently, it means that you have reached your endpoint. You may now close the stopcock and record the final volume of your titrant. Again, when reading the end volume of your burette, make sure that your eyes are at the level of the titrant meniscus. Take your reading from the meniscus. And once completed, please make sure that you discard your chemicals accordingly and clean your glassware appropriately. That is all from us. Thank you.
Okay. Okay, that's about the basic lab skill. Okay, so now please be prepared to be asked a lot of questions before we move to video number 1. Okay, I just want to check whether several of you are actually here. Nurul Syahira Putri Aisyah ada?
Ada, Doktor.
Siapa tu?
Putri.
Putri yang Syahira.
Ah,
Syahira macam mana je nama tu? Betul ke Syahira je nama? SY?
SYA.
Okay. Syahira dengan Putri ada Okay. Putri Aisyah, tadi buka kamera tak?
Buka. Tapi line tak kuat, so kena tutup sebab lag.
Okay, great. Okay. I have several questions, but I would like to give way to Dr. Syed. Dr. Syed, do you have any question to be asked to students about these basic lab skills?
Okay, hi guys. So we done for the second and third. The first one we discussed using the analytical weight, and secondly how to use the pipette, and finally how to do the titration. So my question is regarding the pipette. I want to ask what the name? Yeah, we call Lai Wan Jin. Do you hear Lai Wan Jin?
Yes, doctor.
So it's very easy one. In overall, what is the function of using pipette? What is the function? What is the purpose they are using pipette?
To measure the sample accurately.
To measure the volume.
Yeah.
Alright, fine, thank you. And then we proceed with Muhammad Ahmad, Muhammad Albar
Doctor.
Tati, Ahmad Muhammad. Are you here? Number 14. Number 14.
Yes.
Muhammad.
Yes, doctor.
You here online? Okay, the second question will be, okay, before there is one to get the accurate result in your experiment, what is the most important part you need to do before you use the pipette? Even this procedure also you have to do for the burette as well before you using the burette. What is it the first step that shown by the demonstrator as now? Before you use the paper, what you need to do is the pipette.
I think we have
What?
to make sure it is empty or clean.
All right, fine, thank you. To clean is there, to clean. And then, so we need to ask Wong Chi Tim from the last one, number 37.
Yes, doctor.
What solution you use to clean the pipette? Wong? Are you here, Wong?
Yes, doctor.
Wong Chi
Distilled
Tim.
water.
Okay, this is what fine. Very easy one. And then about titration. And for titration, we go for titration is I have the question here. Maybe I call Ong, Mr. Ong Soyi.
Yes, doctor.
Okay. Okay, there is the whole procedure, last procedure. I mean, before you could start with there is mentioned by the demonstrator how you do the titration process. How you do it? I mean, the reaction, the reagan, how you fill in the chronicle flux. You will do sudden or you do slowly? How slow the titration process?
Slowly, drop by drop.
Fine. Right. Thank you. I think that's all the timing for this moment.
Okay, thank you very much, Dr. Said. Okay, I would like to call several names for me to know that you are here. Is Amalia here? Amalia?
Yes, doctor.
Okay, Amalia here. Last week, you missed the briefing. Any reason that you want to share?
Actually, I'm on my way, so the line is not really good.
So you are on your way from Indonesia?
It's actually I'm in Malaysia, but I'm on my way to Johor.
On your way to Johor.
Yes.
Okay, I wasn't notified beforehand, but never mind. After this, please PM me. Okay.
Okay, sorry, doctor.
Okay. Do we have Ahmad Hassan? Ahmad Hassan?
Yes, doctor.
Ahmad Hassan here. Okay. How about Siti Zakia? Siti
Yes,
Zakia?
doctor, I'm here.
You're here. Okay. Okay. Great. Maybe 2 more names. Okay. How about? Do we have Kavinash over here? Kavinash?
Yes, doctor, I'm here.
Okay. So your clashing of class already settled, yeah?
Yes, I settled the issue.
Okay, great. Thank you. Do we have Shidesh?
Yes, doctor.
Okay, thank you very much. Okay, let's go and continue with our second video. Our second video is about experiment number 1. So this is the experiment of gravimetric analysis. Okay. I believe you already know all this procedure from the lab manual and you even put it inside Jota book. That's good, and this is how you see the real experiment being done in our lab. Okay. Pay very good attention to this video. Maybe I will stop 5 or 7 minutes one and then ask question. Yeah.
Assalamualaikum warahmatullahi wabarakatuh and very good morning. My name is Dr. Faizon bin Abdullah. I'm currently a senior lecturer at the Faculty of Science, University Technology, Malaysia. Today, I would like to demonstrate to you how gravimetric determination of nickel can be attempted. I would like to explain the basic principle first. Dimethyl glyoxine, or DMGH, is an organic precipitant principally used to determine nickel. DMGH selectively reacts with nickel at a controlled pH of between 5 and 11. The formation of chelates between the nickel-2 ion and DMGH can be written as follows. DMGH is almost insoluble in water and is aided in the form of a 1% solution in 90% ethanol. 1 milliliter of this solution is sufficient for the precipitation of 0.0025 gram of nickel. The precipitate form is so bulky that the presence of a very small amount of nickel can be handled conveniently. Nickel is normally precipitated by adding the MgH reagent to a hot acidic solution of nickel-2 ion, which is then made basic by addition of ammonia. Only a slight excess of the reagent should be used since the MgH is not very soluble in water or in very dilute ethanol and may precipitate if very large excess is needed. Now, I would like to show you the apparatus as well as the chemicals required for performing this analysis. As you can see, we require quite a lot of things on our table now. First, we require the use of concentrated nitric acid. Here it is, concentrated nitric acid. Then we require the use of DMG in alcohol. We also require the use of urea, ammonium hydroxide in dilute form, nickel sample solution, litmus papers, several volumetric flasks, a thermometer, sintered glass crucibles, a desiccator with silica in it, beakers and the stirrer, pipette filling and the pipette itself, as well as the washing bottles. Now, the first step of doing this experiment is by pipetting 50 milliliter of nickel sample solution into a 100 milliliter volumetric flask. Dilute to the mark with distilled water, followed by mixing the mixture thoroughly. So this is how we are going to do it. Now, I am going to pipette 50 milliliter of nickel sample solution. You have to measure accurately. Focus on the meniscus level so that you get the accurate amount of volume that you require. It can be a little bit tricky somehow, but you need to get to the meniscus. Well, you can see it can be a little bit difficult to get the volume, but now I get it. So I'm going to transfer this 50 milliliter of nickel sample solution that I pipetted into the calibrated volumetric flask. 100 milliliter for the calibrated volumetric flask to be precise. Upon completion of transferring the sample into the volumetric flask, the next step is to dilute it using distilled water up to the 100 mark for the volumetric flask. You have to do it very carefully, and the final step, perhaps you may want to use dropper to drop little amount of distilled water to the volumetric flask so that you can get accurate representation. Finally. Now, what I'm going to do is I'm going to mix it thoroughly by flipping the polymetric flask like this up and down for several times to ensure homogeneity of the solution. Now,
Okay, I'm going to stop at minute 7 over here, and I would like to ask several questions to students, maybe 4 or 5 students. Please be prepared, yeah? Okay, the first student, lucky student number 1 is Alithia. Do we have Alithia over here?
Yes, doctor.
Okay, Alithia, can you tell me what metal we are analyzing right now?
Nickel.
Okay, thank you. And then next, Fu Yihui. Fu Yihui.
Yes, doctor.
Okay. Dr. Faizwan just now mentioned that the dimethyl-glyoxime, the DMG, love a certain pH range. Can you tell me what's the range? Is it alkaline or is it acidic? That you can remember. Yes? Alkaline? Sure? Fu? So alkaline is it?
Yeah.
Okay, so that's correct. So the DMG love pH range between 7 to 10. Okay, thank you very much. Next is Omar. Do we have Omar over here?
Yes, doctor.
Okay, can we pipette the nickel directly from the reagent bottle? The big reagent bottle, can we pipette directly from there? If yes or no, please tell a simple reason for your answer.
I think doctor no because the safety.
Because of the safety. Okay, can be one of it. Okay, I want related to that question. why we cannot directly pipette from the reagent bottle? Nabila Wahyu Hasanah? Nabila? Do we have Nabila? Hello?
Hello, can you hear?
Yes, I can hear you, but it's a bit shaky in terms of the voice. Nabila, are you in UTM now?
No, I'm in my country.
In your country?
Yes, Indonesia.
Okay, so Nabila, related to what Omar said just now, he said that no, we cannot pipette directly from the reagent bottle. He said something about safety, which is partly true. And what are other reasons that we cannot take pipette reagent directly? Anything
I
that you
think because we need to get more accurate volume.
we need to get more accurate volume. Okay, so what is it relationship with the
And also
pipetting?
to prevent the contamination from
Great.
air.
Contamination, yes, that's the word. We want to prevent contamination for the whole reagent bottle in case our pipette is dirty. Thank you very much. Okay, I don't have any other question, but I just want to ask the attendance from others. Chong Yang Cheng.
Yes, doctor.
Ada ya. Okay, do we have Nurul Khairiah?
Yes, doctor.
Okay, great. We have Supaklit over here.
Yes, doctor.
Okay. Thank you. Let's resume.
What I'm
Pay
going to do
attention, yeah?
is I'm going to transfer this solution into a beaker. Time to ensure homogeneity of the solution. Now, what I'm going to do is I'm going to transfer this solution into a beaker. And from this beaker, I am going to pipette 25 milliliter of each of the solution into 3 different 250 milliliter beakers for the subsequent steps. Now, I'm going to demonstrate to you how I'm going to transfer 25 milliliter of the solution into the beakers. Look carefully, accuracy is very important, especially when you look at the measurement. Then add 100 milliliter of distilled water to each of the beaker, followed by heating it to approximately 80 degrees centigrade. You have to check the temperature to make sure that the solution has reached that particular temperature by using a thermometer. And when you do so, please make sure that you rinse the thermometer to ensure that you are not going to move out any solute from the solution that would affect the accuracy of the determination in subsequent steps. So this step is very important for you to follow. Upon completion, the step can be repeated to the remaining 2 beakers that contain the sample solutions. Now I'm checking the solution to make sure that 80 degrees centigrade has been achieved. It appears that the solution has reached that temperature that we wanted. Now, the next step, I'm going to add 10 milliliter of DMG solution into the solution while maintaining at high temperature. Before the DMG can be transferred into the solution, the DMG must be measured first to ensure the accuracy of the amount. Now, after I'm getting the amount that I'm wanted, I'm transferring 10 milliliter of DMG into the beaker, followed by stirring. Now you can see the color has changed. Next, I'm going to check if the mixture has turned into acidic form. I'm going to use a litmus paper to do that. If the solution is not yet acidic, I'm going to add concentrated nitric acid dropwise until it becomes so. This is how I'm going to do that. Well, as you can see here, after checking the solution with the litmus paper, it appears that the solution is not yet acidic. So it is imperative for me now to add the concentrated nitric acid by dropwise. Where is my concentrated nitric acid? Here it is. Now I'm going to add dropwise of this nitric acid into the beaker. I'm going to stir it for a while, and then I'm going to check whether the pH is turned acidic. Well, using this litmus paper, it can be seen that the solution has turned into acidic condition. That is fantastic. The next step is to add 3 grams of urea into the beaker, followed by stirring again. And then the mixture can be boiled for 2 to 3 minutes and cooled to room temperature for the subsequent process. Now, here how it can be done. Let me show you guys. After adding the urea and stirring, followed by heating it to about 2 to 3 minutes, now it's time for us to cool it down. You have to repeat the step for the remaining 2 beakers that contain the sample solution. Now, I'm going to check my crucibles. It is important that crucibles to be used must be washed with oxalic acid and rinsed using distilled water and let to dry in an oven at approximately 1 degree Celsius. Well, I have my sintered crucible in this oven already. Now, what I'm going to do is, I'm going to remove them and place in a desiccator, close it, and bring the crucible for weighing. Now, this is how I'm going to remove it. Be careful, it's very hot. Yeah, now let's go. Next step is to weigh the crucible. And I'm going to weigh each and every crucible using this weighing balance, one by one. So make sure that your weighing balance is actually working accordingly. Step to 0. Now, I'm removing the first crucible from the desiccator and I'm going to transfer that on the weighing balance. Careful, make sure that you place the crucible at the center of the weighing balance and then close the lid. Now, wait until the number becomes constant. Wait, look at the number, right? So it's still moving, wait until it stops. Okay, now you can see that it is stopping and the weighing, where the weight of the first crucible is 5.129 grams. Right, I'm going to record that and transfer back the first crucible into the desiccator, followed by the weight.
kering macam nak remove calculator lah. Terkenal function. Turn the from the silica. Silica. Bawah tu. Silica. No. Silica. To protect the sample from the humidity. Kayaknya bagi proteksi tak sendiri tak. No. Boleh tapi tak accurate kan? And slow. Yeah. No. Yes, sir. To get accurate result, I think. Hello. Yes, sir. Saya I think to get the accurate result. Hello. Yes. Hello. To get the accurate result.
DMG? Why do you think?
To get more accurate result.
To get more accurate result, okay, if I do 4 also accurate, 5 also accurate, but why 3? Anything else that you want to try? Yes, that's correct. That's the ultimate goal. Anything else? Hello? Nurul Fatin? No idea. Okay, thank you. Chuan Shin, Pu Chuan Shin, do you want to help Nurul Fatin?
Maybe is to get the average of the result,
Mm-hmm. And then?
and then um,
Okay.
and then the result will be more accurate.
Okay, that's correct. Nurul Fatin, and you said that is to get accurate result. Yes, you want to get average out of it. And why do we prepare 3? Because that's the minimum number of replicates in analytical chemistry, or maybe any other experiment from any chemistry branch as well. That's the minimum, whereby we want to see whether we have variation. That's the reason. We want to see whether we have variation from beaker 1, 2, and 3. And if we do have variation, how much is that variation that we can tolerate? Okay. So next, do we have Rodiyatul Ahya?
Yes, doctor.
What kind of reaction was happening inside the video? What kind of reaction between the nickel and the MG? Only one word. What kind of reaction? From the way you see the colored compound and so on, what kind of reaction is it that you can guess? Rodiatul? Hello? Kalian dengar ke?
Yes, doctor.
So Rodiatul? So if you do logbook, you already know this answer. Rodiatul, what's the answer? Rodiatul? Ni pay attention tak ni? Lab ni. So what is the answer? Rodiatul, okay, tak apa. I'll keep you in view. I will ask another student, Surin Nash. Ada? Surin Nash?
Yes, Dr. Surin here.
Surin, what do you think direction? What's happening? And based on your manual, what is that reaction?
Neutralization, Doctor.
Sorry?
I believe it was neutralization, Doctor.
Neutralization. Okay. Good answer, but it's not correct. Sorry. Okay. Not neutralization. Siti Nurliza. It is not neutralization. What is the reaction? Siti Nurliza.
Doctor.
Yes. What is the reaction just now? Surin Nasha say is a neutralization. However, unfortunately, it's not correct. Do you want to have a try, Siti Nurliza? What reaction is that? Rodiato, if you find the answer, you can. Sorry?
Silation.
Silation?
Yeah.
Silation tu apa? Silation Macam mana eja tu? How to spell that?
CHELAT.
Oh, chelation.
Chelation. Oh my god. Sorry, doctor.
Saya ingatkan silylation sebab kita ada juga ada silylation reaction. I thought. Okay, so it's chelation
Yes.
Chelation is the process of the DMG and also nickel. That's correct, chelation reaction. And actually the generic term for this chelation and complexation and all, we call it as precipitation reaction. Okay, tadi Suridnash already say neutralization is actually in the same group lah of wet chemistry, but precipitation is the correct term. Siti Noliza. Okay, last kita ada 2 orang lagi. Okay. Okay. Siapa? Sarwin, do we have you here? Sarwin?
Yes, doctor.
Okay, Sarwin, just now Dr. Faizwan showed that he put the thermometer inside the beaker and then he put the thermometer just like hanging in the solution, not at the bottom of the beaker. Why do you think is that?
To show the accurate temperature.
To show accurate temperature. Okay, that's the ultimate goal, but technically why we cannot put on the bottom of the beaker?
I think because it will disturb the temperature. Maybe it will increase the temperature because the surface of the beaker will in contact, so it will show a increase in temperature than a normal. So maybe that's the reason.
Okay, that's actually an accurate reason. So we don't put the thermometer on the beaker, the bottom of the beaker, no contact whatsoever at the bottom, at the side, whatever, because we don't want to disturb the temperature that's happening right then. Okay, thank you very much. Soalan, saya dah habis soalan. Rodiatul last ni. Rodiatul stay here ya. Do you remember from the video what is the range of the crucible weight, crucible mass from the analytical balance? Any number that you can remember?
5.0792 to 5.129.
Okay, great. Seems that you already jot down everything, Okay, thank you very much. Yes, it's between 509 to 512, okay? So, it's already 10 a.m. on the dot. That's good. I plan to finish everything by 10 and everyone already answer questions as well as answer the attendance. So, this is going to be happening for the rest of the experiment because we want to see whether you are paying attention or not. And for lab report submission, it's supposed to be on week 4, next week. Next week tak ada lab, there's no lab next week. Week 5 we will meet again for video discussion, same like now. Okay, if you don't have any more questions, we will finish here. Okay, thank you very much. Thank you, Dr. Syed. Thank you, Dr. Izian.
Okay, thank you, Dr. Imi.
Thank you, everyone.
Doctor,
Ya, siapa tu?
it's me, I'm Hassan.
Okay.
Okay, so for next week, we only need to submit the lab report, right? So do we need to enter WebEx or just finish the? Yeah.
No WebEx session as well.
Oh, okay, doctor. Thank you.
Okay, thank you.